In this video, we're going to be solving a variety of equations that technically all of them which can be done in two steps. Some have more than one options. We've got a combination of negative x terms and fractions to deal with here. So the first one is an example of there being two different ways of doing it. So the first is to treat the x as being the center of the universe and try and get rid of everything else that's with it. So we have this negative 3 that's multiplying the x. Then we have this plus 20 that's happening afterwards. Remember, this can also be written as minus 3x plus 20. So that plus 20 is the first thing that we need to get rid of. So I'm going to take away 20 from both sides. Now, if I take away 20 from both sides, I'm going to write this a little bit to the left. We're going to be left with negative 3x equals negative 6. And then to get rid of a negative 3 that's multiplying x, we divide both sides by negative 3. That will leave us with x on the left-hand side, and minus 6 divided by minus 3 will give us 2 on the right-hand side. So that's the first option. The other option is to treat the fact of, well, there's minus 3 x's on the left, and there are no x's on the right. So technically, you can add 3x to both sides if you choose, in order to make the x's become positive on the right-hand side. So in order to make this disappear from the left, basically, we would add 3x, and then if we add 3x on the right-hand side, we'd end up with the following. 20 equals 14 plus 3x. And now you've got an equation, the likes of which we've covered before, where we can take away 14 from both sides in order to get rid of that plus 14 that's with the 3x, leaving us with 6 equals 3x, and then we divide both sides by 3. We'll get x equals 2, or 2 equals x, the way it's written. Now that technically has 3 steps to it, but if you prefer to avoid negatives, then that might be something you choose. Either way, the solution is the same, and the strategies work for both. The second one also has 2 different strategies. The first one I'm going to approach is basically along the lines of, well, what is happening to x and in what order? So as it stands, we have this divide by 3 happening, and then a plus 5. So we're going to want to get rid of that plus 5 first, because it's further away from x. That will leave us then with an x over 3 equals 2, is what you'll have on the right. Then in order to get rid of that over 3, we've got to multiply both sides by 3. And we'll be left with x equals 6. And the next one, the order is a little bit different here. We have a takeaway 3 that is right beside the x, and then all of it is being divided by 4. So technically, when you have this on the top of a fraction, there's like an invisible pair of brackets there that don't need to be written in. So you have the takeaway 3 happening first, then the division by 4. So we've got to multiply by 4 first to get rid of that fraction, basically. You'll be left with x minus 3 on the left, because all you were doing was getting rid of the over 4. And then on the right-hand side, you will end up with 20. And then from here, we've got to add 3 to get rid of the minus 3. And that will give us a solution of x equals 23. Next one, there's 2 ways of doing this one as well. So I'm going to show both ways here. The first is, if you treat this as having 5 over 1, then you can technically flip these fractions. You flip the fraction on the left and you flip the fraction on the right. Now this only works if you have a situation where it's fraction equals fraction. So there's one way of doing it. And then after that, we need to get rid of this over 20, divide by 20. So we multiply both sides by 20, and we'll end up with x equals 20 times a fifth, which ends up being 4. Now, the other way that you're more likely to see is what I'm going to show you on the right-hand side is when you have a letter on the bottom of a fraction, that's a big problem. You never want denominators with variables on it. So that's actually the first thing that we could get rid of here. Now, in order to make something you don't want disappear, we've got to think of what will be the opposite of dividing by x. So what's a little strange here is that we actually multiply both sides by x. So we're actually doing a sum to both sides that involve the x's here. But that's the quickest way to technically get rid of that problem, which is over x. If you do that, the left-hand side you'll have 20, and the right-hand side will be 5 times x, 5x, and then from there, get rid of that 5 that's multiplying, divide both sides by 5. You'll end up with 4 equals x. Same solution either way. The next one, similar situation to the first one, I think it was the first one. Yeah, where you've got a negative x term. So there's two ways of doing this, but I'm just going to show the way that I would do personally. I'm going to add x to both sides. I'm going to add x to both sides. Wrong color. Because you generally want to avoid having negative x's. So we have 23 equals 12 plus x. And then I'm going to take away 12 from both sides in order to get rid of that 12 that's being added to x. And that will give us 11 equals x. Next one. We have a divide by 7 and a minus 2. Now, there is another way of doing this, which I'm going to show you. So it's going to be different from what we did here, but either way works. One thing you can do whenever you have fractions is just multiply everything by whatever it takes in order to make that fraction disappear. So everything is going to get multiplied by 7. So when you multiply x over 7 by 7, you'll end up with just x. We have to be careful here because of the fact that we have a minus 2. That thing needs to get multiplied by 7 as well, giving us minus 14. And then the right-hand side will give us 21. And then from there, we can add 14 to both sides. And we'll get x is 35 as our answer. But if you prefer the first way that I showed you, then you could have just added 2 to both sides first and then multiplied both sides by 7. It doesn't really matter. It's your choice. Next, we have a plus 15 going on and then an all over 2. So we've got to multiply both sides by 2, which will leave us with x minus 15. So x plus 15 on the left and 6 on the right. And then we're going to take away 15 from both sides to make that plus 15 disappear. And that will give us x equals minus 9. Next one, I'm going to multiply both sides by x in order to get rid of that over x, because that's a problem whenever you've got letters on the bottom of a fraction. So that will give us 12 on the left, 8x on the right. And then divide both sides by 8 in order to get rid of that multiply by 8. We'll end up with 1.5 equals x. You could also leave that as 3 over 2 equals x if you want. Either is fine. And then the next one, we're going to add x to both sides because we want to have the x's positive. So we're going to end up with 8 on the left equals 14 plus x. And then we're going to take away 14 from both sides, giving us minus 6 equals x. Done.